I'm here at DAppCon in Berlin, and I've been going around talking to people about projects they're building on and discovering some of the things people are building in the Gnosis chain ecosystem. And I met up with
Evgeny.
Evgeny, how are you doing?
Doing great. Great conference.
Yeah.
Like the weather.
Yeah, the weather's pretty good. I mean, we're doing this on a boat right now, which is really cool. So yeah, you work at Fluence. You're one of the co-founders of Fluence. Tell me a little bit about what you guys are doing and why it's interesting.
Yeah, we are working on a decentralized compute network, which is basically the decentralized analogy of traditional cloud providers like Amazon, AWS, Microsoft, and Google. And basically, we are providing the infrastructure and development stack for developers to build and deploy applications to such network, and do not depend on centralized like vendors, and don't have vendor lock-in, and avoid this link or dependency on centralized infrastructure providers.
Yeah, so I mean, in the crypto space over the years, there's been lots of projects doing decentralized compute. So we have things like, iExec, Golem, I think, was also an early project that was trying to do something, at least I think with a similar vision. How is Fluence different from those, and perhaps, how does it build on some of the cryptographic primitives that have come since then? Like, how is it better in the next thing as opposed to some of the earlier examples?
Yeah, I think the main thing here is basically like two things is security model and the developer experience. And like every project took different choices in terms of how their security model would work. Like, for example, you can create a network where people can run nodes and be the providers of computational power, but they would not provide you any verification of the computation that they run, so you need to rely on the reputation of a particular node. And this is the choice that you can make when you're building the decentralized computing project. And I think earlier projects, they followed only this direction of a reputation-based networks. And at the other side of spectrum, for example, there is blockchain networks where all the nodes are the same and they have consensus for every transaction. They also computational networks, but they verify every transaction, every state transition that happens in the network. And that puts a lot of constraints on amount of data. They can put amount of processing power that they can have as a network. And this basically makes the cost of computations work quite high. So what we are trying to do is the flexible peer-to-peer network, which is off-chain. There is no global consensus or global state. So every node is different, and every node can serve different applications. But the application developers that can ask some nodes where they deploy their code to verify each other work. For example, if you want, you can ask the nodes to deploy some consensus algorithm if you need verification, or you can select the nodes that are most trusted at the same time. So we kind of combine this verification way to the ability to verify the computation and the reputation-based system. And we're gonna have more of this, but it's also plugged to how our economics works.
So if I understand correctly, the verification mechanism in order to verify the computations are actually done are not part of the stack, but it's something that you can add on, and it's got more modular.
Yeah.
So you're sort of modularizing the decentralized computation stack by offering the sort of way for people to build a network around decentralized computation and then get to build whatever stack they need in terms of consensus, in terms of verification, in terms of economics. Is that?
Yeah, so the verification is pluggable and customizable. So let's say, for example, you want to have an oracle for you're building a smart contract and some on-chain application, but you need some data to come to your on-chain application from the off-chain world. And you basically need to have some off-chain oracle, and you can build this on Fluence by saying that you want to create a subnet, deploy your job, the computation job, on several nodes, and then you can basically program whichever algorithm they should follow in order to verify each other. For example, you could program the simple parallelization of like deploying tasks to several nodes and then asking them to find the average, and this data you would just put to the chain as a result of your Oracle job. Or you can say that you want like 10 out of 20 to get exactly the same result of the computation, and you will have like 10 signatures under this result, and this you would think that this is the like verified computation when you submit this on-chain. So the on-chain contract will see 10 signatures and it would say, okay, this is secure, I trust this data.
Okay. What ecosystems are you guys building on? Is this a product that's easier to integrate for EVM chains, or are we also considering other ecosystems like Solana or the Interchain?
Yeah.
Or what? Yeah.
So the network itself is like chain agnostic. So like it's off-chain, it's a peer-to-peer network. You can think of this as like IPFS is a peer-to-peer network to store data, Fluence is a peer-to-peer network to run compute. And you can plug different data, basically sources, to this network. And you can plug blockchains, you can plug decentralized storage like IPFS, Filecoin, RVF, and stuff like that.
That's cool.
Yeah, and on the chain, like if you take use case of when you want to process some on-chain data, compute on it, and then put result back on chain or store it into storage, we have currently built-in adapters to Ethereum mainnet, to Near, and working on like adding a few others. But like potentially it is possible to plug Fluence to any layer 1 or layer 2, like any chain.
Yeah.
It's just like the question like how fast we build this adapter, so community builds these adapters to chain.
Okay, so a contract, you could have a contract that is doing its thing. It can call on Fluence to execute a complex computation that you say couldn't do on Ethereum just because it's too computationally hard. Fluence comes back with a callback and returns the data or returns the result signed by, say, like a consensus of nodes that have verified the data.
Yep.
The contract moves forward once like these parameters or like these criteria have been established, and then like it keeps doing its thing.
Yeah. So this is the Oracle use case, and this is basically one of use cases that's possible. But there's also could be like a vice versa use case when you have the Fluence code that pulls events from the chain, and like if
computes,
you have a cron job on Fluence that executes like once per second, and then it queries data from the chain, and then when it got the thrown event, it runs the computation, and then it's, for example, again submits the result on chain, or displays or sends a message somewhere in the notification to user. So you can have these bots living off chain, reacting to on chain events.
So you could build like some sort of a like decentralized data layer, where it's like computing on-chain data, something similar to like the graph, or
you can do like some data processing or indexing, or you can like have some trading bots, for example, build with it. Or there are some use cases like where in DeFi you need like some liquidation protection, like you need to look where is the price, and then when the price is close to the liquidation price, you need to put additional liquidity, for example. So you need to have off-chain bots that monitors the on-chain activity. And you can do this for analytics purposes, like you can build some local indexes of some smart contract or set of smart contracts, or some subset of data, and basically like all the things that you put right now in the cloud, in centralized cloud, you potentially can do here.
Cool. And what are some of the things that people are you live, or people building on Fluence already?
So the network, the off-chain network is live already. The only thing that you cannot pay right now on the network. So in the cloud, you sign up, then you put your credit card and you pay, and they provide you available service. Fluence network right now works like IPFS network, so it's non-incentivized. That's why you cannot really pay to some node and to provide you some available resources. And that's why you basically can either rely on some nodes that we as Fluence Labs running for community, or you need to run the node for yourself, which makes sense when you're developing the application. But when you go to big production environment, you want to have something like really provided for you by professional computation providers. So we are not there yet. The payment layer gonna probably come live next year. but the off-chain non-centralized network is live. And
so like to analogize here, like it's the IPFS and Filecoin, like the economics are
exactly.
separate from the computation computation network. Okay,
yeah. So economics is coming, the computation network is live.
Cool. So what's on your roadmap? Like other than this year, like what kind of things should people expect from Fluence in the next couple months?
We actively researching and looking into different use cases. Like, for example, this Oracle use case is only one thing that you can do. The other thing that you can do, for example, is you can create like decentralized infura on Fluence, for example.
Yeah.
You can.
Oh, that's cool. Yeah.
You can basically like have some resolvers into RPC requests, like load balancing RPC requests, or like failover. You can have failover if like the first node that you query doesn't answer, you can failover to the other node. So you can build this distribute algorithms that you can have in the cloud as well with their load balancer tooling and then routing and API gateway. You can have it here, but here they work in a decentralized fashion without any centralized coordination place. So you should check out our developer tooling. It's pretty cool.
Where can people find more about that?
Yeah, so the biggest steps for us, one of the biggest steps is we want to launch the DAO. We want to start the DAO that would govern the whole protocol, and after that, we probably launch the payment and incentive layer.
Okay.
And on the we constantly do some new stuff on the development stack level. So we issue updates a lot of stuff.
So what's the website? Where can people find more about Fluence?
It's fluence.network.
Okay, cool. Yeah. Thanks for being on this short Interop interview.
Thank you for having me.
And testing out this new gear for the first time. I hope it works out.
I hope the sound is good.
Thanks.